Welcome to this explainer, where we're going to unpack a seriously dramatic, high-stakes story about the true intellectual origins of artificial intelligence. If you've been following the absolute explosion of AI lately, you might actually think it's this completely modern phenomenon. But the blueprint, and honestly, the really intense battle lines of the field, they were actually drawn over half a century ago. So the central question we're diving into today is this. How did a 2-month summer camp essentially invent AI? And then, how did one densely mathematical book almost completely destroy it? We're going to explore this massive whiplash between the boundless, sky-high optimism of 1956 and the absolutely crushing mathematical reality check that hit in 1969. Section 1, The Birth of AI. Okay, let's dive right into this. To really understand where we are today, we have to travel back to the early 1950s. At that time, the field didn't even have a unified name. You had researchers working under this whole messy collection of competing labels, things like cybernetics, automata theory, information processing. It was basically this fragmented landscape just waiting for a spark. And that spark, well, it arrived in 1955. John McCarthy, who was this young assistant professor of mathematics at Dartmouth College, submitted an incredibly ambitious proposal to the Rockefeller Foundation. He boldly wrote that the study was to proceed on the conjecture that every aspect of learning can, in principle, be so precisely described that a machine can be made to simulate it, use language, and improve itself. It was right there in this very proposal that McCarthy strategically decided to coin the term artificial intelligence. He was basically trying to create a neutral banner to unite all these disparate fields. This exact proposal is what led to the Dartmouth Summer Research Project on Artificial Intelligence in 1956. But you have to realize this wasn't your typical rigid, stuffy academic conference. No, it was more like an 8-week, highly stimulating brainstorming summer camp held right on the top floor of the Dartmouth Math Department. Brilliant researchers just came and went, debating the future of thinking machines in this wonderfully unstructured, chaotic way. The core organizers of this event, they're now widely recognized as the true founding fathers of AI. We're talking about John McCarthy, Marvin Minsky, Nathaniel Rochester, and Claude Shannon. They were the ones who secured the funding and brought together literally the greatest mathematical minds of the era. The conversations they had that summer essentially initiated major directions in the field, especially the rise of symbolic methods and the early groundwork for expert systems. And the rapid momentum right out of the gate, it was unbelievable. Think of the 1956 Dartmouth workshop as the Big Bang of AI. Just 2 years later, in 1958, Frank Rosenblatt invents the Perceptron, which sparked this massive wave of excitement. But then, fast forward just a bit to 1969, and Marvin Minsky and Seymour Papert published their highly critical book Perceptrons. Let's look a little closer at that fascinating middle period. Section 2, The Perceptron Promise. We're shifting gears now to look at the immense excitement that followed Dartmouth, which was largely driven by psychologist Frank Rosenblatt and his brand new invention. So what exactly was a perceptron? Well, in the simplest terms, it was an early artificial neural network developed in 1958. It consisted of a retina to receive inputs, a single layer of input functions, and a single output. It was basically an abstract mathematical version of a learning device, and it very quickly became one of the most famous, most hopeful machines of its entire era. The expectations for these neural networks absolutely skyrocketed in the 1960s. I mean, you had reports in the New York Times, along with bold statements from Rosenblatt himself, claiming these machines would soon be able to see images, beat humans at chess, and, get this, even reproduce. The optimism was just off the charts. AI was being portrayed as if it was on the verge of solving virtually everything. But let's take a step back and look at the massive gap between that promise and the actual reality check. While the hype promised machines that could see, play chess, and reproduce, the harsh gravitational pull of mathematical reality proved otherwise. Single-layer perceptrons like the ones being hyped up couldn't even compute basic logical functions like the exclusive OR, or XOR. This glaring, fundamental discrepancy is exactly what brings us to Marvin Minsky and Seymour Papert. Section 3, a mathematical roadblock. So Minsky and Papert decided to write a theoretical account of the actual limitations of perceptrons. It actually took them years to finish because as they wrote, they kept uncovering more and more unexpected math problems. Finally, in 1969, they published their rigorous, mathematically dense book, simply titled Perceptrons. To make their case, they placed a core restriction on the models they studied. They called this concept conjunctive localness. Now, that sounds complicated, but it's just the idea that effective neural computing must rely on a simple parallel combination of local information. In simpler terms, each unit in their model could only receive connections from a tiny local part of the overall input area. Working within this specific framework, they mathematically proved some extremely severe limitations of single-layer perceptrons. First up, parity. This means the network literally cannot determine if the number of active inputs is odd or even. Second, connectedness. It fails the figure ground problem, meaning it can't easily tell if a shape is a single connected object. And third, the famous XOR affair. It cannot compute the exclusive or logical predicate. Basically, to use a metaphor here, these single-layer networks were fundamentally blind to global patterns because they were only ever looking at isolated, tiny, local patches of information. Section 4. The XR controversy. Now, what's really interesting about this is the human drama that followed, because this wasn't just some quiet academic debate. The publication of this one single book ignited a massive scientific controversy. Let's examine the two sides of this intense debate. On one hand, the neural network community felt Minsky and Papert unfairly killed neural nets by implying that larger, multi-layer networks suffered from the exact same limitations as the single-layer ones. Meanwhile, the authors themselves pushed back, defending their work by arguing that multi-layer nets were just a sterile extension, and that other proposed models would require an enormous, completely impractical number of masks to actually work. So there was this genuine, incredibly heated debate over whether Minsky and Papert intentionally tried to bury neural network funding just to favor their own approach, which was symbolic AI. So the really crucial point here is how this theoretical information was practically received in the real world. A highly specific mathematical proof concerning a global issue like parity not being detectable by local detectors was broadly interpreted by the wider community, and much more importantly by funding agencies, as a successful attempt to bury the whole idea of neural networks entirely. It was basically taken as a death sentence for the perceptron. Section 5. The AI winter. And that brings us directly to the fallout of this controversy, ushering in a remarkably chilling period in the history of the field, known today as the AI winter. Following the publication of that 1969 book, the entire landscape shifted dramatically. Funding and top talent were aggressively diverted away from neural networks. Instead, all those resources were poured straight into competing symbolic AI systems. You have to remember, computing power in the 1970s was incredibly limited and expensive. So researchers had to fight tooth and nail for every dollar. The Perceptrons book effectively starved neural net research of that funding for over a decade. Even later, when neural networks experienced a major revival in the 1980s, Minsky and Papert absolutely doubled down on their initial assessment. In the 1988 expanded edition of their book, they wrote, "Little of significance has changed since 1969. Any single homogeneous machine must fail to scale up." They argued that the perceptron died because of its own inherent credit assignment problems and an inability to scale, not simply because their book killed it. Ultimately, the legacy of the Perceptrons book is this really stark reminder of the underlying tension between theoretical mathematics and the practical pursuit of artificial intelligence. We see this super clear narrative arc. The boundless, almost naive optimism of that Dartmouth summer camp eventually required the harsh, grounding reality check of Minsky and Papert's rigorous math. It was a really painful roadblock for sure, but it eventually forced the entire field to reevaluate, dig deeper, and actually evolve. Which leaves us with one final, pretty provocative thought. If the early AI pioneers, literally some of these smartest mathematical minds in human history, couldn't predict the limits or the ultimate potential of their own creations, what massive blind spots do we have about AI today? Are we currently living right in the middle of a brand new era of hype, just waiting for our own mathematical reality check? It's definitely a fascinating question to consider as we watch this incredible technology continue to unfold. Thanks for joining me on this explainer, and keep learning.